Hi class, so today we're gonna start with Seaborn. So we look at um, the lecture for this week is going to be Seaborn. There's gonna be 6 different topics that we're gonna talk about. So make sure that you download your uh, file on Colab. So you just click download, right? Download it to your computer. Then you will go to your Colab. You can then click open lab and then choose you would choose the file that you want to upload, right? Click choose file, and then and then you will be able to see the notes. Okay, so please follow along. Make sure that you're keeping up with it because you're gonna submit this at the end of your of the watching the 6 different sessions. Remember, each section is 1 point for engagement, for participation, right? It's a good way to make sure that we are following along with the lecture and that you're being active. And it's going to help you process and understand the information a lot better, right? So let's start with distribution plots. So Seaborn allows us to be able to have different ways of displaying information. We're going to be able to show you guys 5 different ways the displacement plot, joint plot, pair plot, log plot, and the KDE plot. So we'll talk about those different when we get into each one. All right, so let's start with the first one. And before we can actually start doing anything with Seaborn, we need to import Seaborn. So we're gonna do import Seaborn, and like we did it before with NumPy, we use import NumPy as MP or pandas as PD. We're gonna import Seaborn as SNS. Again, it is just a shortcut to refer to the library Seaborn. It is not a rule, but it is something that a lot of us follow. Everybody in the industry follows this style. Okay, makes it easier for us to refer to the library without having to write Seaborn. It's like how we refer to Joseph as Joe, how we refer to Jonathan as John, and Pat for Patrick, and so on and so on. So it's a shortcut to refer to the whole name, right? So the first thing that we're gonna do is we're gonna build in a data frame, a data set. Okay, so as Seaborn has a way to extract some data that is in the library so that we can play around with it and apply different tools as part of our learning. So we're gonna extract this information from the library. So we're gonna use SNS, which is Seaborn, and we're gonna look at the load data set. And there is a information data called tips, and so we're going to be extracting the tips from the library of Seaborn. Okay, we could download it from somewhere, from other places, but right now we're just trying to learn the different ways of plotting using Seaborn, right? So that's the focus right now. It's not the focus of extracting information, so it is for us to understand how to implement this different ways of displaying the data using Seaborn. Okay, so we're gonna run it, make sure that this is okay. Then we're gonna do is let's check the first 5 elements or rows of our data. So you can see now that our data, our tips, contains our index row 0, 1, 2, 3, and 4. It's going to contain a couple of columns: total bill, tip, sex, smoker, date, time, and size. Okay, we could do and check the last ones if we want to, and that's just doing by tail, and we can see the last one. So this one has 244 different rows, in other words, data. 244 because it starts at index 0, so That's why if it goes all the way to 243, we have one extra, right? So 244. We could also do things like we can see that the information about this specific data. And we can see here that there's about 200, like I said, 244 entries, right? From 0 to 43. And every single column has an entry. There's 0 null data. So that's always good to know. We can see what kind of data type each one is. So this one's a float, category, category. So like practically like an object. This is an integer, right? And we can see how much memory is using. And here we can see the three different data types that this data frame contains. And you can see the class. We can see that this is a data frame from pandas. So that's why it's being displayed in that form. We can use all these nice methods and attributes if we need to. Okay, so just to show you, right, a little bit of what kind of data we have, right? It's always good to know the data that you have, so be able to see how you're gonna implement it, right? So right now we just want to plot information. So I added another row just so we can follow along with what we want to see, right? So it's taking a while. Oh, seems like all of them are not running. So, oh, they're back. Okay, there you go. All right, so what we're gonna do now is let's do the first plotting. So we want to plot the information about our tips, and we just want to see specifically about, let's say we just want to see the total bill, the information about the total bill. Okay, so we just want to display information so this is going to show the distribution plot of my tips. So if I want to access just the total bill, I have to refer to the data frame, which is tips, and specifically call the total bill. Remember when we talked about pandas, we talked about how to extract a specific column in our data frame. So this is grabbing just the total bill of my tips, and that's what we're going to be able to display here. So you can see here that our X value will be our total bill, and then we're going to be able to see the price that we get from that, and then the distribution form. So remember, this is doing a distribution. So the result is based on finding using the distribution formula for our total bill values. Okay. If we want to see the actual formula, I can actually put it here. So I'm gonna put it right here so that we can see what the actual formula is. Okay, so this is using this formula to be able to distribute our tips values. All right, let's say we don't we want to be able to we don't want to see that line. We can do it without that line, and so that's practically the KDE layer, which is the kernel density estimation. So let's say we want to remove that. So what we can do is again do the same thing, SNS, which is the SNS, the Seaborn. We're gonna do the distribution plot. We're gonna base our data on the tips again. We're gonna look at the total bill, and what we're gonna do here is we want to remove the line. So we're gonna say our KDE, our kernel density estimation, will be false. So if I do that, we won't see the line anymore. So that's good. So that's just in case we don't want to see it. But let's say we want to go a little bit further, and I want to be able to control how many bars I want to see. So if I want to specifically make it a little more precise, I can say how many bars I want to see. So bins will be referring to the number of bars. So let's say I want to have 30 bars. If I do 30, then you can see that this will be showing a lot more bars, which allows us to be a little more accurate, right? It wouldn't be doing a lot. It wouldn't be doing as much approximation, and so it would show the actual a little more close to the actual value. All right, so sorry, I just paused it so that way we don't have to, wait for it. So you can see that now it has 30 more. It has 30 different bars instead of I think this has 10 or something around there. So you can control the number of bars that you want to see, and you can see that it's a little more accurate. And if we put 100, that would be a little more, even more accurate. So you can control it if you want to, if you need to. All right, so that's the this distribution plot. So we're seeing the distribution on the total bill. Now, what we can do here is now let's talk about the join plot. So what we want to do is we want to be able to compare multiple values, multiple columns with each other. So, for example, let's say we want to compare the total bill with the tip. Then what we can do is, and we can actually show them, right? We can actually display them as a distribution and the actual scatter and how they would scatter around a two-dimensional space. So here, what we can do is we can say SNS, which is a Seaborn. We're gonna do a join plot, so we're gonna join two graphs. X, we can say which one, whatever we want to be our X, either the total bill or the tip. It doesn't make a difference. So I'm just gonna have the total bill be my X, and my Y would be my tip, and my data is my tips. So I'm grabbing the data. My data is my data frame, which is in this case tips. I'm gonna use a what kind of a plot that I want to compare them, and that will be a scatter. We can change it to regression or a KDE or hexagonal, whichever we want, right? So we run this. All right, so there's an error. I missed the T join plot. So let's see. There you go. So as you can see, on the top we have the total bill, and in the left side and the right side we have the tip distribution. Because we're using X and Y as your total bill and your tip, there is a way to coordinate them and plot them in a two-dimensional space. So you can see here how this is scattered around a two-dimensional space. You can analyze the relationships between them. We can do the same thing for and change it to a different type. So we can do, instead of being a scatter, we can do a hexagonal. So we can do instead of being a scatter, we can do hex, and you can see that we would be able to display the same thing, but now with, instead of a point, will be hexagonals with different colors displaying the concentration of values around that area. So if there's more on this area, right, then the color will be stronger than if you have less elements on the or points in an area, you would have a lighter color. So the more concentrated points will make it more, the color will make it a little more darker. And it kind of, you can see it right there. All right, so we can do it like that, or we can do a regression. So a regression will add a line to the actual data of our scatter line. So we can see this, and you can see forming a regression line, anticipating a regression line for the data that we have here. And so, which kind of makes it nice, so that you can actually do a prediction if you need to. We will talk about regression in machine learning in a few weeks. But here it actually is making a regression line for this data already. So in a way to predict where the tip will be according to the total bill. So if according to this, right, if you have a total bill of 50, it says here that they should be paying about $6, or most people will pay about $6. Okay, and so that's that. Now let's look at a way to correlate relationships between different data types. So we know we have 3 different rows, right? We have the total bill, the tip, and the size, and we want to see if there's any correlation between them. And so what we can do here is to be able to check if there's any correlation between the columns in our data frame. What we can do is we can call in the Seaborn hair plot, and what we're gonna do is we're gonna use the tips data frame. And so what we're gonna do is we're gonna pair different columns with each other to see if there's any relationship, and we're gonna be able to just see any graph. So we can see here from this graph that the tip and the total bill have a kind of linear relationship, right? And it kind of makes sense, right? Most people would follow that if you have a bill of $100, then you tip about what, 20% or something like that, or some people would do 15%, but something around that range, right? So they kind of have a standard of, most people, right, have a standard, so that means that there's probably a relationship between the total bill and the tips, right? And so you can see here by doing this that there's a relationship between them, and you can actually do also other analysis like size and total bill to see if there's any relationship that you can capture from there, so to visualize it. So, and we can also add different colors to it. So let's say I want to be able to distinguish between males and females. So right now this is all mixed up. There's no separation between males and females. But let's say I want to see how a male versus a female will tip. And so what we need to do is, because we're looking at the differences on the males versus females, right? So we're gonna look at the column sex as our base comparison. So what this is going to do is going to separate the values dependent on the male and the female, giving them a different color. So to give them a different color, what we're gonna do is we're gonna use a palette and refer to that as a cool warm. Okay, so there's different palettes that we can use. Let me see. Here, there's different palettes that you can see here. So if you look at Seaborn palettes, you can see the different colors you can do. So yeah, so so you don't have to memorize them. You can just Google them. Like you can see here, cool warm. That's the one I'm using right now. But I could use seismic, ice fire, whatever, red and blue, yellow blue, right? So there's different ones that you can use. But right now I'm just using cool warm for my the separation of colors. And what this is going to do also is going to be able to create some legends on it, to be able to emphasize that, which one is male and which one is female. So whatever we have in our column, in this case, we have males and females in our sex columns, then we would be able to separate between those. If we had more, then it would automatically separate between those. Let's say we have 3 different, or actually 4 different sex values, then this would automatically change the colors on it, and we use the cool warm to represent each color. So you can see here that it shows which kind of separation between males and females, right? So it seems like in here it doesn't show, maybe, let's see, tips and total bill. It seems like in correlation, males and females tip about the same, right? So if you can see, if you draw a line on each one, then you will be able to see that they both practically have the same projection on tips. Okay, so now what we're gonna do is we're gonna do a rug plug. And so in order to be able to do a rug plug, we're gonna use SSN rug plot, and we're gonna pass in the information that we want to look on, which is total bill. So what a rug plug does, it concentrates all the data on a single horizontal line. And you can see all the distribution is within the same, the horizontal line in the bottom part. So you're concentrating all the values on practically the rug, right? Like the floor. So that's practically what this is doing. It's not something so fancy, but maybe we can see it to represent maybe DNA. Maybe could. All right. So we talked about the KDE. It's the kernel. What was it? The kernel density estimation. Yeah. So there you are. Yeah. KDP are the kernel density estimation plots. This KDE plus replace every single observation with the Gaussian normal distribution center around the value, for example. Okay, so this practically what it does is just gonna replace the Gaussian normal distribution. But let's see an example of the KD plot. So this is what this is going to do, right? So it's gonna have a bunch of different distributions depending on the concentration of each element, of each data. So how do we do that? Well, let's start by importing numpy. So as np import matplotlib dot pyplot as plt, and then we're gonna do from sciencepy import stats. We're gonna create a database here. Data set equals to np.random.rand .25. And so we're just creating data sets here, right? Then what we're gonna do is we're gonna create another rug plug. So rug plot data set, and what we're gonna do here is we're gonna set the axis for our plot. So we're gonna set our minimum from our x will be my data set dot min. So I'm gonna grab the minimum value from my data set and I'm gonna subtract it by 2. So just to give us some space. And I'm gonna do the max. My maximum value for my x will be my data set dot max. And I'm going to add 2 so that way I can have an extra space on my x-axis, just so that we can see a little bit more beyond just the actual point. And what we're gonna do here is I'm gonna create some values for my x. So let's create some x values. So I'm going to say my x-axis will be represented by my NP, my NumPy line space. And what I'm going to do is from my x min, so this is going to allow me to create my labels for my x-axis. So I want to create some labels where I can actually focus, right, my points. So I'm going to have my x min, my x max, and then I want that to be, I want to have 100 points between them. And then what we're going to do here is so here I'm gonna put a website that if you want to learn more about the bandwidth, you can check it out. So I'm gonna put it right here, copy. So this talks about the relationship estimation of the bandwidth in referred to the kernel density estimation. So you can check it out. It's very heavy math. So I'm not gonna go over that part, but you can check it out if you want to. But that's not necessary for to do this. So we're gonna do, I'm gonna assign my bandwidth to be equal to 4 times my data set dot std times 5, and then divided by 3 times my length of my data set, close parenthesis, times, square, 0.2. Let's see, I think I have an extra parenthesis. Am I missing one? That's 2. Oh, I forgot to put a parenthesis there. All right. So that's my data, my bandwidth, which you can get from the formula from the Wikipedia. We're gonna have our kernel set, and we're gonna make it an empty one for now. And what we're gonna do here, since we're gonna have to iterate through every single distribution, what we're gonna do is we're gonna create a for loop that goes through every single point in the database, the dataset, and apply our norm function. So we're going to use stats.norm to normalize the values of our data point from our data set using the formula from our bandwidth dot pdf x-axis. And then we're going to take that kernel and add it to our list. And then we're going to plot that. So we're going to say kernel equals kernel divided by the kernel dot max. That's just to scale the numbers within from 0 to 1. And we're going to do kernel equals kernel times 0.4. And then we're going to plot that using our x-axis, our kernel data, color gray, and alpha equals 0. So we're gonna make it a little bit transparent. We're just gonna now plot everything with our limit from 0 to 1. Let's see if that works. Let me put pause here just while this is processing. All right, so I need to add plt.show to be able to see the graph. As you can see, now we can see the distribution of the data from our tips. No, actually from the data we created. And so, and there you go. So let me continue with the next one. We don't use that one as much, so that's why I don't want to focus much, but we can just do it. So I just wanted to show you an example of the KDE. So let me show you guys another example. So we're gonna do the sum of the KDE, and we're gonna do the numpy sum of the kernel dot list on the rows, and then we're gonna plot the figure using plot with our x-axis the sum of the KDE, color, India. We're gonna do an Indian red, and then just to do a different color, and then we're gonna do some. We're gonna put in the rug plug. So we're gonna do CNS that rug plot data set dot c equals to the India Indian red. Call it red. This is just red. ELT dot y tick. So we're gonna display our ticks to be empty, so we don't want to show anything. And then the title will be subtitle would be the sum of the basis function. All right, so we can see that, and I think two more. Practically, what we're gonna do here is we're just gonna straight use the the kernel density estimation plot, and we're just gonna graph the total tips. I'm sorry, total bill. And with the rug pull. So you can see here how we can do it manually, or we can just use like how we did it manually here, or we can just use it using the two graphs, the two methods from it. Why is this one? The sum is not the same. Interesting. We get this tip on the top. But anyways, um, let's see. Let's do the same thing now with the tips. Anyways, all right, so we can just use the straightforward, the KD plot or the rug plot to actually just create those two graphs where we have the kernel density distribution implemented on the graph. Okay, so this one's a lot of the KDs we don't use it as much, but we do use a lot of the pair plots to be able to compare, find any relationship between our columns.